I am José Valim, and you're listening to the Changelog.
Welcome back, everyone. This is the Changelog, and I'm your host, Adam Stacoviak. This is episode 194. It's a big show today. We got José Valim on the show. We learned about the early days of José's start as a programmer. José took us back to the beginning of Elixir and shared why Erlang got him so excited. We broke down the features of the language. We talked about functional programming. We talked about concurrency, developing for multi-core systems. We talked about the Elixir community, the future of Phoenix, Ecto, and so much more. We had 4 awesome sponsors: TopTal, Rollbar, Linode, and TrueSight Pulse. Our first sponsor of the show is our friends at TopTal, an exclusive network of top freelance software developers and designers. Top companies rely on TopTal freelancers every single day for their most mission-critical projects. At TopTal, you'll be part of a worldwide community of engineers and designers with the flexibility to travel, blog on the TopTal engineering blog, apply for open source grants, or for scholarship options for our fellow women developers out there. Lots of opportunity inside of TopTal for you. Head to toptal.com, that's TOPTAL.com to learn more, or email me at adam@changelog.com if you'd prefer a personal introduction to our friends at TopTal. And now, on to the show. All right, everyone, we're here today talking about Elixir. And Jared, you know, we've wanted to have José on the show for so long. We had several issues come up, and José, I think you and I might have exchanged some sort of GitHub message way back in the day, trying to get you on the show when you were still working more so on Ruby.
Yes,
but it's been a long time coming, my friend.
A lot happened in those. I don't remember when we talked, but when I look back, there are so many things that happened in the last 5 years, which is just crazy.
And Jared, like any good show, it begins with an issue. So how did this one come about?
Yeah, multiple issues, like you said, over the years. I think the last time around was like the end of 2014, and we couldn't quite schedule it out or line it up with José, but we had Chris McCord on the show to talk about Phoenix specifically, which was a great episode. If you're interested in that, check out 147, which was like last March. And that kind of counted for our Elixir show for a while. And then recently, in December, José, one of your counterparts there at Plataforma Tech, George, help me with the name, José.
Jorge Guimarães.
Yes, so shout out to George for hollering again and saying, you know, we've had some big milestones in Elixir 1.2, or is it Ecto 1.2 and Elixir 1.1? I can't remember the exact version numbers. And it's time to get him on. And Elixir 1.2, Ecto 1.1. So thanks, George. And José, we're really happy to have you on the show.
Thank you. I'm glad to be here as well. You had Chris back in March last year?
Yes.
Oh, so we have a lot to talk about. A lot.
Yeah, lots changed in Phoenix as well, right?
Yes, I think March, it was not even 1.0 yet, and I think March was when I was actually starting to contribute to Phoenix, or I had just started, and then we had like this great let's say sprint where Chris and I were working and we were improving things, and I think we got like the 1.0 about July, something like this, kind of middle of last year.
Yeah, so we have a ton to catch up on. Adam and I are quite excited about both Elixir and Phoenix, so we have tons of questions for you, José. One thing we like to do kind of as an intro to the show is to get to know the people behind open source, because we find that's super interesting and enlightening. So from the internet, you know, and from following you and your work, we know a little bit about you, which is that you're a Brazilian and you live in Poland. We know that you crank out a ton of open source stuff. You also seem to be, just from my experience online, like a super nice and a positive person, but we don't know very much about beyond that, really, of your background and how you came to be where you are. So we love to hear developer origin stories on the show. And so if you're willing, we'd like to hear kind of your origin story, where things began for you in software, and then how did you get where you are today?
Oh, okay. So I would say things like my first real contact with software was at university. I went to do so. I grew up in the center of Brazil in a small city called Inhuas, and I moved to São Paulo, which is big city and everything, for studies to do my university in which ended up being automation and control engineering, which I don't use for anything, but anyway.
Mm.
And the first year I had C programming, and that's how I started with programming. And I have very good, and I have very good memories from those classes because I remember, the professor would program in the whiteboard, which is a little bit weird, but he would say, now you need to declare this variable like int, the variable name. And he would say, you need to do this. And then every time he said, like, you need to or you must do this, I would ask, why? What would happen if you don't? And he was like he was a little bit peculiar, the professor, but he would always like entertain my questions. But at some point he got like he couldn't take it anymore, and then he like, why do you want to do it? You're a software, like you need to follow those rules.
Yeah.
Why are the rules in place, man? Tell me.
Yeah, exactly, right. I just wanted to know what was going to happen, and but he said that like it was also interesting because you would say like, oh, the variables would need to be initialized, right? But in C, if you don't initialize, something is going to happen. It's just going to have whatever is in memory, and those weird questions actually made him like tell this stuff as well. Right, like what are the consequences if you don't do something? So I think we could learn, and hopefully I was not just the annoying person in the classroom getting in the way of teaching. But that was pretty much like my first contact with it, and then it's still in the first year in university. Me and a couple friends, we had a band. It was an acoustic band. And one of the players of the band with me is Hugo Baraúna, which is a co-founder of Plataforma Tech with me.
Wow.
So we had like a lot of story together that started exactly in the first year of university. And we had a band, and I decided to make the website for our band using Flash and ActionScript.
Nice.
So this is like the first time I was like, hey, I'm going to learn things for myself, and I'm going to try to make this work. And I was doing it out of, it was not because I had classes. Even though I enjoyed like the C classes, I was actually doing this because I wanted to learn. And that went pretty much like that. I also remember that at some point I started learning more about databases. MySQL probably at the time, and then I ended up going to do PHP and MySQL. It was a very short period of time. I did a couple projects as a freelancer. I remember like a couple interesting stories as well, because we were still in the band. I was always very passionate with music. I remember that at some point when I was still in university, I went looking for like music schools, like I don't know if it's conservatorium in English or how you say that. And I remember that I was checking on the internet which ones had really horrible website. And I called them and I was saying like, hey, if you give me like classes on singing or guitar, I'm going to do a new website for you. Like if you give me 6 months of classes, I'm going to do a new website for you. So that's something that happened at the time.
Did that work?
It worked. I got my 6 months of singing classes. Yes.
So you're basically trading websites for educations.
Oh, sorry.
So you're basically trading website work for an education in singing.
Yes, exactly. I couldn't afford the singing classes at a conservatorium. Those are usually really good. But so that was a plan that worked. They're like, well, we would really appreciate a new website. So yeah. So. So it was pretty much that, nothing serious, just doing things on the side, even because the engineering university was, required a lot of time. And it was at the end of 2006, I had, we were a couple friends, and that was when I actually met George that got us here on the show. It was about 2006 that we got closer. And then we had some ideas for startups. and Rails was already, a lot of people were talking about Rails, and I decided to try it out, and that's when I got started with Rails, and yeah, and then a lot more happened regarding that. I was doing Rails for quite some time, and at the end of my university they have an agreement between so at that point I was still in Brazil, but the university had the engineering school had an agreement where I could go on and do my last year university in another country, and that's when I moved to Italy, and that's when I left Brazil. And it was really funny because when I left I was like, the whole course was like 2 years that what I had to finish. And then I was thinking, well, you know what? I'm just going to go stay there 6 months and then come back. I'm not even going to do the whole 2 years. And then I never came back. I'm still here. Yeah, but that's how I went abroad. And that's kind of what explains how someone from Brazil it's
Yeah.
living in Poland. I met my wife. My wife's Polish. And now I live here. I'm living here in Poland for 5 years.
I was gonna ask what kept you in Poland, but then you told us you found a wife and
That's right.
settled down. So
Good reasons.
congrats on that.
Yes, exactly. Thank you.
So you mentioned you were doing Rails work, and many people, I think, probably in our audience who know you and may not yet know you with regard to Elixir, probably know you with regard to the Rails work that you did, which started off as devise, right? Or maybe that's not the starting point, but that was the gem that you and your team at Platforma Tech built that became kind of one of the de facto, authentication tools that people use on Rails even to this day. Can you tell us about that, kind of that section in your software career with regard to devise and working with Ruby and then eventually on the Rails core team?
Sure. So, yeah, it was a little bit before that, and there is a very nice story here because I remember my first open source contribution, which we had. This was probably back 2006, 2007, and we had a plugin called Upload Column, if I remember correctly, for Rails, and I remember sending a patch by email to the author, like, hey, what if we did those changes? And it's really nice because I later, the author, the owner of that package is Jonas Nicholas. And, he went to write Capybara. He wrote Carol Wave and the new Refile plugin for Rails. And this goes like way back, and probably 2006, 2007, like we were exchanging these emails, we were exchanging patches. And it's nice because recently he started coding with Elixir as well. So that's a fun side story. But that's like what I remember as like my first like dabbling at open source. And a couple years later, I think this was 2008, 2009, I actually created something called inherited resources, which was, I don't know if you ever got to use it, but it was the first thing that started that I've written myself and started to gain some like attention. I don't remember, for those who are doing Rails for a long time as well, I don't remember the time, but we also had something called Rails Footnotes, which was a plugin that you could install in a Rails application, and it would add a bunch of footnotes at the bottom showing like what was the request parameters, what was in the logs. So it gave access to a lot of information. It would show like which queries ran and how much time it took. And I also contributed to that. But the first one was exactly inherited resources. And with inherited resources, so this, if I remember correctly, was 2009, and we had the Google Summer of Code happening. And this was when Rails 2 was starting to become Rails 3, right? The work towards Rails 3 had already started. And Google Summer of Code was happening, and I was still a student at the time. So I wrote a proposal for the new generator system, which I still think is the generator system using today in Rails. And the whole idea of the proposal was, Rails 3 is meant to be agnostic and everything, right? Like you can bring your own ORM layer, you can bring your own like test framework. but then I said, like, we cannot really say that Rails is going to be agnostic if the generators, they are still going to generate only active record stuff, right? Like at Rails 2, if you're using RSpec, you need to use like RSpec scaffold, RSpec model. They could not play together. So I wrote this Google Storm of Code proposal, um, and for the new generator system, and it was accepted. I worked with Yehuda Cat on that. He was my mentor, and that's how I started to. It was really a great opportunity because contributions on GitHub was not that easy at the time. Like how it was new still, so it was hard for you to be really in touch. Like with the people actually building the software,
Mm.
and it was really hard because I got really close to Yehuda. We became good friends, and that's how I got like my first big contributions to Rails. And then I started contributing more and more. Eventually became part of the Rails core team. It was also at the time that we started Devise, and Devise it was started as part of Platform Attack. We
Hmm.
hired at the time our first person. We were in 2009. The company had just started, so we were the four founders, and we hired Carlos Antonio, and one of the reasons we hired him was exactly because of his other contributions to other open source projects, and he started working on Devise, and we were working it together. I was kind of more of doing a mentorship role in those initial days, but then Devise grew up. A lot of people started using it, and it's our biggest open source project for the Rails community in particular, and we have other ones like Simple Form and so on.
Yeah, I actually had forgotten about inherited resources. I recall it now, and as you spoke about it, it kind of reminded me of what you were mentioning back with your professor in college asking why. Because correct me if I'm wrong, wasn't the purpose of inherited resources was to really dry up the controllers quite a bit inside Rails and remove a lot of the kind of the boilerplate, which is scaffolded out in a typical Rails controller. And it just seems like that was you basically asking why with regards to how we do controllers in Rails and kind of your answer to a different way of doing that.
Yeah, so the whole idea is that you would inherit resources base or something like that, and
Right.
it would bring the whole it would have a default implementation that does everything the Rails scaffold is supposed to do. And this is usually like what your controller typically does is that you need to have like the query part where you need to say if I want to get the current uh, the current manager for this project inside this company, you need to build the query, right? And often using things from sessions. So that was one thing. And the other one is how to render those resources.
Mm-hmm.
And that's kind of what was in there together. And eventually, at this point, if you go to the inherited resource project, they're going to say, hey, don't use this. We don't maintain this anymore. We don't recommend people to use it. Exactly because it just hides too much. We if at some point you say like, the scaffolding Rails, there's a lot of boilerplate, and inherited
Right.
resources has none. We had to find a balance somewhere, and inherited resource was too much to the extreme, to the point you would look at your controller and you're not really sure what it is doing, or you would have to, or you would customize like one of 20 callbacks, and then you actually have not a lot of confidence of how that works.
Yeah, that's actually my exact experience. I had one situation with it. I actually inherited a project that used it, and it took me a really long time just to figure out what was going on because like where was all this activity coming from? And then once I realized it, it started to make more sense. But again, like you said, it's funny. Like the question is why? Why are we doing this boilerplate? And it's a super useful experiment to like let's see if we can just dry this up and not have to do it. And then over time, you learn. Well, it's also helpful for it to be obvious what's going on, and so you're hiding a lot under the covers there. Um, so yeah, interesting stuff. And so Devise came later and was, like you said, part of Platforma Tech. We're gonna go to a break here real quick, but can you just give us a real quick synopsis of your company, Platforma Tech? You said you founded it with 4 other people and its purpose and kind of how it plays into open source.
Sure. So, Platform Tech, we are a consultancy based in Brazil. I said like 2009 we were four, but now we are about 40 developers, and we work with both well-established startups and big companies, Fortune 500, for example. And what we're really good at is to go there, and if you're having hard problems to solve, right, we come in and we're trying to make your whole process around the software development more efficient. And the relation with open source was exactly when we started, um, was I was I was doing open source, so we started us four, and for a while we didn't have any clients, so I had a lot of free time, and that's when I wrote inherited resources. And we what happened at the time is that we started to get a lot of clients because of our open source work. So we knew at that point, like, hey, investing in open source, besides, it also helps us to grow the company. And as I said, the first person we hired was also because of the open source contribution. So it's not we can get clients, right? We can also, it help us to attract good talent. And that's how it was a relationship with open source. But and it changed a lot with Elixir. I would think, because with Elixir, it was when we decided to make a huge bet, right? When you say, like, hey, I want to invest in a language, we are no longer talking about making a small project for the community. You're talking about investing on something for a long period of time that has also higher risks, because you can invest for like 3 years and nobody uses it, right? So what's going to become of that?
We did a great job there teeing up the next segment of the show, Jose. We obviously want to dive deep into that big bet you mentioned, which is Elixir. So we're gonna take a break. Great learning about your origin and all that. I guess it will definitely dovetail quite deeply into your passion for multi-core and Elixir. So let's take that break. We'll dive deep when we come back. I'm excited to tell you about a new sponsor of ours, Rollbar. One of the most frustrating things about being a software developer is dealing with errors, relying on users to report your errors, digging through log files trying to debug issues, or a million alerts flooding your inbox and ruining your day. With Rollbar's full stack error monitoring, you get the context, the insights, and control you need to find and fix bugs faster with a lot less noise. Rollbar is easy to install. You can start tracking your production errors and deployments in 8 minutes or less. And Rollbar works with all major languages and frameworks, including Ruby, Python, JavaScript, PHP, Node, iOS, Android, Elixir, and more. Integrate Rollbar into your existing workflow, send error alerts to Slack or HipChat, or automatically create new issues in GitHub, Jira, Asana, Pivotal Tracker. And we have a special offer just for you, our listeners. Go to rollbar.com/changelog, sign up and get the Bootstrap plan free for 90 days. That's basically 300,000 errors tracked for you, totally free. Rollbar is loved by developers at awesome companies like Heroku, Twilio, Kayak, Instacart, Zendesk, Twitch, and more. Give Rollbar a try today. Head over to rollbar.com/changelog. All right, we're back from our break. We got José Valim here. Long time in the making, this show, as many shows, Jared.
Yep.
It came from an issue, but it goes much deeper for you, José. You came from Ruby roots, and you came from roots where you kind of got, I don't want to put words in your mouth, but it seemed like you kind of got bummed about the lack of multi-core systems and concurrency and all these other things that the other languages bring. And obviously, we've got Elixir now. So maybe let's begin with that. Tell us a story about how it began for you and Elixir. Where were you at with Rails? Where were you at with Ruby? And what kind of sparked this interest of multi-core, concurrency, and ultimately Elixir?
Yeah, that's a great question, because I was working with Rails, and I was one of the ones not responsible, but working with making Rails thread safe. And it was really, really hard, and we worked a lot on making or improving Rails. So if you go back in time, like Rails 2.3 said that Rails was finally thread safe, but it was thread safe by putting a huge lock around your application, right? Which is not what you want because you're not going to leverage concurrency. And then we wanted to improve this more and more of time. It was a lot of work. And then when you thought like, hey, I can finally make this work, then you realize that it doesn't work on JRuby or Rubinius because they give you different guarantees regarding thread safety. So it was really frustrating work. It was, and as you know, like if you're using threads and mutexes and so on, and you have a lot of state around, which is what we have in our regular Rails applications, sometimes you don't know that there is a race condition or there is a concurrency bug in there. It's just when you're running in production under certain scenarios, or in particular some high loads, right, that those issues they are going to show up, and then they are even harder to debug and try to give a guarantee to say for sure, hey, this is thread safe. So I was working with that, and then what came to my mind was that, I was already hearing, this was, I think, 2010. I was already hearing like, concurrency is becoming even more important. That's why we want to try to save in the first place, right? So we could get our Rails application, put it in a server in production, and if it had like 4 cores, it would use all the 4 cores efficiently without needing to restart 4 instances, for example. So I knew that. I knew it was becoming important, but I said, like, if this is going to be the future, right? If the future is going to have like 8 cores, 32 cores, or 128 cores, we needed to have better abstractions because the ones I had working with Ruby and Rails, they were not going to cut it. So I decided to study other languages and see what they are doing. And the idea was exactly to kind of see what is happening there and try to bring it into Ruby and into Rails. And I spent a good period of time studying other languages and so on. But the one I really, really loved was Erlang. And the reason why I really liked Erlang, as not only the language but also the whole virtual machine, was exactly because to me they were not doing the concurrency. They're not worried about concurrency. They're actually worried about distribution, right? You're not writing software and they're saying, oh, I want to make this software concurrent. You're saying, hey, I'm writing this software and this software can be distributed, which means it can run on multiple machines, right? It just happens that our model, when you're running multiple machines, it can also happen that you can run everything in the same machine and you get concurrency for free. So I'll expand a little bit on that, which is, so when you're writing software in Erlang and now today in Elixir, all of our code, it runs inside the processes. And the Erlang virtual machine is like, it's 30 years old. It has been there for a while. And when they were writing it, they were not worried about concurrency, the multi-core concurrency at the time, because you didn't have multi-cores at the time. But so when you're writing Elixir code, you have your code running in processes, right? And those processes, they're not operating system processes. They are very lightweight threads of execution. They are very cheap. You can create literally millions of those. And it was everything done in a way where, I can have a process running this machine, I can have a process running on another machine, and as long as those machines they are connected as part of our cluster, they can exchange messages between them, and all those processes they are running at the same time. And that's what they built at the time. And then when they needed concurrency, they just realized that concurrency is the special case where you have all those processes, but instead of them running in different machines, they're only running the same machine. So you can get a little bit extra guarantees for that, but it's really a special case for the model they have that. And when I saw that, I found it beautiful, right? Because if you think like we as a software, the industry is changing, right? Now we are hearing more and more languages oriented towards concurrency. It may get at some point that we're going to hear more and more languages that are oriented towards distribution. And Erlang is already there. It has been there for 30 years, right? So that was really fascinating to me. And I was like, if I want to write software in the future, I want to write software that's going to run on this virtual machine. And that's what got me excited and led me down this path.
So just to give us some context, what year was this when you were formulating, you were conceiving the idea of Elixir? Like, give us a time period.
This was 2010 and the beginning of 2011. So okay. The first commit to Elixir was like January 2011. And it was the time I started. So after that, I started writing more and more Erlang. But there were a couple things that I really feel like it was missing in the language. The way I like to sum it up is that I liked everything I saw, but I hated the things I didn't see. I wanted, for example, really good Unicode support. I wanted good abstractions for working with collection, things that I was used to, right? And I could
Mm-hmm.
not really give up on them. So yeah, go ahead.
Oh, I was just gonna say, it sounds like the programmer happiness angle that Matt's took with Ruby. It spoils you when you get
Yeah.
used to it. I know I'm spoiled in many ways by it, and I look for those features everywhere else I go, and I judge other languages in terms of semantics and syntax with regard to how I can express myself. And it sounds like you're hitting that same thing where like everything you saw about Erlang, the foundations, the distribution model, all these things were great and you loved it, but there was just missing pieces that you just didn't feel like you could live without. Because if you could have lived without them, you could have just kept writing more Erlang, right? But you decided, no, I'm going to actually start something new that's going to be kind of a melding of these two worlds. Is that fair to say?
Yes, that was kind of the it was not the idea at the time, but it
Mm-hmm.
what it came to be. So at the beginning, so like I say, the first commit was January 2011, and so I knew what I was missing, but I was not sure what I wanted, if that makes sense. So
Mm.
for example, I was like, oh, I want better support for collections, or I wanted a way to do polymorphism. So the first, if you go like to the early commits of Elixir, to the early history, it was actually an object-oriented language. It had a prototype-based model, and but everything in their virtual machine is immutable. So I was
Mm.
trying those things. So I know I had a problem and I wanted to solve it, but the answers I had at the time, they were very Ruby centric, let's say. So it was more guided, biased towards object orientation, and however Ruby was solving those particular problems. So,
Mm.
for example, metaprogramming, it was a metaprogramming similar to Ruby, where you when you need to do fancier things, you need to be doing class eval with strings and things like that. So I knew I had like those problems, and I was trying to solve them. And then I played with it for 3 or 4 months, and the end result was really really bad because I was like, I know I had those problems. Those are the solutions I know, and they didn't map really really well, right? In the sense that the things I was trying to bring was not going to fit in this new ecosystem, in this new way of doing things. So
Mm-hmm.
I stopped working on Elixir at the time, and I said, okay, I know those are the problems, and I know that some of the solutions I'm looking right now, they are not going to fit. So I need to study more. I need to see how other languages they are solving those problems and how they can fit into this new into this virtual machine. And
Mm.
so that's when I started to say, okay, so I don't want like Ruby in Erlang. I actually want, I want to solve those particular problems. And if I need to take some ideas from Ruby, I'll take some ideas from Ruby. But if the best ideas they are from Python, that will fit here, they are going to be from Python, they're going to be from Haskell, or they're going to be from Clojure, and so on. And yeah, go ahead.
Yeah, I was just gonna say, I mean, that's very interesting. It kind of reminds me of what Jeremy Ashkenas did, with CoffeeScript back in the day, which was, I'm not just gonna do a nicer syntax or a Ruby version of JavaScript. I'm actually gonna pull in what he considered and what the community considered best ideas from all these different camps, specifically. But that Python plus Ruby was major influencers. Um, so I mean, yeah, that's definitely a winning strategy. It's like, you're not just let's just not take Ruby ideas and move it over here to Erlang world. Let's actually like come up with the best thing we can for each given circumstance. But that seems like a really big green field, and there's so many decisions to make. Was it daunting? Were you intimidated by this task that you had just taken on?
That's a great question because I think a lot about it. And one of the things that makes it really easy is that, if you're building software, if you're building a language on top of the Erlang virtual machine, there are a bunch of decisions that they are going to be taken for you. Okay. So
Mm.
that narrows a lot the scope of what you can do, which is, it helps you it helps keep you sane, right? Otherwise it would be too much. I already feel like, being a engineer, being a software developer, I want to build the best software I can possibly build, right? And sometimes I have like those things that, I see something different, I see something new, and I ask, should Elixir be using that instead, right? How could, how would that affect the language if I had made this other decision? And those things, they can be quite consuming, because also, um, if the answer was yes, life was going to be much easier, because you say, okay, I know how to make this better. But the answer is not yes, it's maybe. You need to consider how it interacts with the other, all of the other things that you have in the language, right? I say, like, it's like a Jenga game. You need to have like the pieces well together, and sometimes you can, take a piece out and put a better one in place. But maybe you do that, and you're going to continue building on top until you find out that, oops, that piece was a bad piece. So yeah, so I get that a lot, and I say joking that it's something I would never do again, create another programming language, because of all those questions that you can have. It's just such a wild scope, and you cannot really, choose how, like, this is 100% better than the other. But the Erlang virtual machine helped a lot, so I could get a lot of concerns. I got a lot of things like, okay, even if this is cool, I know I can have it here, so, and that's fine, right? That's life. And I also, when I decided, so after I studied and I decided to give Elixir another try, I had a better foundation of what I wanted. So I said, for example, okay, if I'm building for the Erlang virtual machine, one of the things I want to do is to leverage this virtual machine as efficiently as I can. So I made a decision to, I want to stay. So when you're compiling a code, you have like many compiler steps. And I decided to target a compiler step that was semantically very close to Erlang. And that would add even more constraints, right, to language development. So that helped a lot. I also had already made decisions on what I wanted the syntax to be, and that I wanted to have a macro system based on ASTs and so on. So all those things that were like initial decisions, like this is what I want to build on top of, helped make it a little bit less daunting.
So did you just go into a cave for 2 or 3 years and write code? Or, I mean, you obviously were taking influence from other places. Were there any books? Was there any influence when it's like, I'm going to write a programming language? Sounds like you had at least a second start there, which is always nice to throw away those first efforts and start over when you have a little bit solid foundation. But what was the process like from maybe not to 1.0, but here's a new guidepost. So in 2013, there's a post by Joe Armstrong, who I'm sure, Jose, you know, but to the audience, he's one of the designers of Erlang. And he published a post about Elixir. I think it was called 1 Week with Elixir, in which he said, and I quote, "This is good shit." So I think that's a milestone. I think that feels like a milestone to me from conception in 2010 and a false start to a certain degree, or a restart in 2011 to 2013. One of the inventors of Erlang is impressed with what you've done here. Can you walk us through that time period and the process you went through to create it?
Sure. So at the beginning of 2011 was when I made the prototype. It sucked, and I threw it all away. And then it was the end of 2011, the ending of 2011, beginning of 2012, where I've built a conceptual model that I said, okay, I think this can work. And this was also the period where I went to Platform Attack and say, okay, I think we can build this thing, and I think it can be useful. Because at the time, we were looking at what I said was something like, concurrency is becoming, that thing I just said, concurrency has become more and more important. And today, if you want to use a language that, for better or worse, is it's a dynamic language, and it focuses on concurrency, and it focuses on productivity and being expressive, the option we had at the time, the main one was Clojure. right? So, if you get something like you have Ruby and Python, but they are still not concurrency oriented as those other languages, right? You have Go, but it has a static type system. They are not very focused on being expressive as a developer, right? So I said, like, the only language that has everything that I could think of us using at the time was Clojure. And I said, we need to have more options, right? And it would be really nice to have an option that runs on the Erlang virtual machine. And that was January 2012. And it was when the company made the commitment to, okay, we are going to like to invest part-time, half of your time into developing this. So that helped a lot, right? Because it was not me being, coding at night or something like that. It was part of my job from that moment. And so I had this idea of what I wanted the language to be. So as I said, I wanted to be closer to Erlang, and I knew I wanted a macro system. I knew I wanted for polymorphism, for example, I had completely ditched the idea of objects at this point. I end up implementing something that's very close to Clojure protocols, and it's similar a little bit to type classes in Haskell, and a little bit of interfaces in Go. It's kind of the same idea. So that was like, okay, that's what I wanted to build, and then I started working on it. And I don't remember how much time it took me, maybe 6 months to have something like, hey, I kind of feel comfortable now for releasing Elixir, what I would say like the 0.5, which is what people use when they say like, okay, this is probably usable up to some extent. And I also made the plan, I think it was even the beginning of the year, to speak at Strangeloop. They had at the time an emerging languages track. And I went there, I was able to speak about Elixir. It's probably one of my first public talks about Elixir. And at that moment, some people already started to find it. So I always had access to a good part of the community. Like a lot of people follow me on Twitter and something like that. So I was always talking a little bit about it. And some people, they decided to try it out and they decided to explore the language. And some people started contributing back. So we see a little bit of a community forming and important contributions to the language. They came about that time. So, for example, one of my favorite features we have today is the idea of doc tests. So the here doc syntax we have, like if you want to do a very long text, right? We got it from Python, and then someone said, Python has this doc test thing. Since you already got the here docs, look at the doc test, which allows you to write documentation or tests inside your documentation. Then you can guarantee that the documentation is up to date, right? And that's something we got at the time. It was a contribution. So the language was growing a little bit. I was pouring my time. The community already started to help it grow and help it move forward. And it was, I think, so, and then it was, that was 2012. Right, I was working on it. The company was investing it, but I was always a little bit uncertain, right? Because like I know the company was investing in it, but for how long they're going to actually invest in it? Like if we spend 2 years working on this and nobody's using it, does it make sense? So I always had like the feeling that maybe next year it's going to be my final year working on this. And yeah, it was, but it was like, if that happened, it was like, oh, the ride was fun, right? Like, I learned a lot, and people, use it and enjoy it. So that was worthwhile. But it was in 2013 that we had like 2 very good news, in a row, which was Dave Thomas. He sent me an email asking if he could publish a book about Elixir. And a little bit actually before that, also Simon St. Laurent from O'Reilly, he wrote Introducing Erlang, and he said, I want to make this Introducing Elixir too, which is probably the first Elixir book announced. I don't remember which one of those 2 they came. And it was just fantastic, right? Because now it's like there are other people, effectively investing on the language as well, right? And, like, one of the things I had in my mind is that I didn't want to write a book on Elixir. I felt like, well, maybe this is something it's probably going to be necessary in the long run, but I don't want it to be me. But if nobody does that, I'll probably do it, let's say. And and then Dave Thomas come and say like, hey, I want to write the book. Like, that's great, right? Like, it's Dave Thomas. he wants to write the book. So
Yeah.
that was very exciting, and that
It's a big
was
deal.
yes, and that was what led. I think it was Dave Thomas that led Joe to do that, because Joe, he got to know that Dave Thomas was writing a book on Elixir, and I was like, okay, I need to try this, uh, and we started growing more and more from that moment on.
So surely you read Joe's post and you saw the quote, you saw his take on it. Can you recall your thoughts and feelings with regard to Elixir when you see one of the designers of Erlang saying that it's good?
Oh, it was really great. I don't remember exactly, but um, Joe and Robert, they're both creators of Erlang. They were always very open, and we could always have conversations. Also, the OTP team at Ericsson that maintains Erlang, they were always very open. So I remember when I first announced it, Elixir, the tagline was Elixir, a modern approach to the Erlang virtual machine, and it was a horrible tagline, but the modern word
Mm,
made some people mad, and
mm,
and I remember getting an email from someone at at Ericsson say like it's fine, ignore that, just continue building cool stuff, right? So that was very encouraging, and getting Joe's feedback and later Robert feedback and so on, it was also very encouraged to continue um, doing the work, right?
I just want to point something out here for the listening audience, just in case they didn't kind of hear what I think I heard, which was, here's you, and everyone sees you as this really great software developer, especially with all the success with Elixir, and they see you. To what you just said, basically, was that you got a couple years into this and you thought it might not work out, and then you sort of hit this stride where I'm sure one of your heroes, Dave Thomas, who wrote the Ruby programming book, which is the most bought Ruby book ever, I'm sure. So here's one of your heroes, bless basically what you're doing, and then want to write a book about it. Like how that all worked out to me is just like a really triumphant moment for you.
Yes, it was like those things that give you a lot of confidence, right, to continue moving forward.
Right.
And
You're going the right
it
way.
yes, it takes the the uncertainty, which helps a lot, right? Removing that uncertainty that I may not be working on this next month, right? So
That's
that was
crazy.
really nice. And the benefit of it is that I became closer to Dave Thomas as well. So when we had the first Elixir conference, uh, it was in Austin, and my flight was in from Dallas, where he lives. So we took a car ride. We were able to talk a lot there. Sometimes I'm like wondering things. I have like the perk of being able to send like Dave Thomas an email and say like, "Hey, what do you think about this?" Right? So those were very nice perks that came as consequence of the book as well.
Well, I'm going to tee something up for you, Jose. Before we head to this break, I'd like to hear from you what some of the overarching features of Elixir are. When we come back from the break, we'll dive a little deeper into some of them if we can. But do us a favor, share kind of an overarching feature set for Elixir.
Okay, yeah. So that's really hard. So I like
you can do it.
so yeah. So Elixir. So the main thing is that you're going to use it to build maintainable and scalable applications. But we also Elixir is also an expressive language. So we want to allow that thing like developers, they can get the language. Actually, I'm not going to say expressive. It can be expressive as well, but extensible. They can get the language. That's always on the ideas language to be able to get it and extend it to whatever domain you're working on. And the focus on productivity as well. So we have very good tooling. So I would say so that's like the macro overview uh, of what you can build with the language. And then features, there are so many, but I think like the tooling it's really fantastic. I like features like focus on documentation and um, and what else? I like our the way we can do polymorphism, which is a language specific trait in this case, and so on. I'm not sure
That's
if
a
I
good
gave a good
breakdown.
answer, but yeah, that
That's what we're looking for. I mean, we're getting ready to go into this break, so we wanted to kind of get a breakdown to leave the listeners hanging, so to speak, a little cliffhanger, so to speak, on what Elixir is built upon. Like, I think the plain language in which you put it in wasn't like, here's the feature list of Elixir. It's more like, from your mouth. So I mean, from in your own words. It wasn't like this scripted list.
Cool.
Jared, anything you want to add before we go to the break?
No, that's good. I've been writing those down, and we have a list of things that we can definitely use as jumping off points to talk about on the other side.
Cool. Let's take that break. We'll be right back. Our friends at Linode are huge fans of the show, and many of the developers that work at Linode listen to the show. They're huge fans of what we're doing here, and they want to support what we're doing. And we want to invite you to try out Linode, one of the most fastest, efficient SSD cloud servers on the market. Use our code changelog20 to get $20 in credit, basically 2 free months. Plans start at just $10 a month. They have 8 data centers spread across the entire world, North America, Europe, Asia Pacific. They got hourly billing with a monthly cap on all plans and add-on services. You get full root access for more control, run VMs, run containers, or even your own private Git server. You can enjoy native SSD storage, 40 gigabit network, Intel E5 processors. Again, use the code changelog20 to get a $20 credit with unlimited uses. Tell your friends. It doesn't expire until the end of this year, so use it as many times as you want. Share it. Tell everyone you know. Head to linode.com/changelog to get started. All right, we're back from the break, and we got this feature list, and we're looking at it, and one of them stands out more than the others, and it's maintainable and scalable applications. How do we quantify that? What exactly does that mean? How do we break that down, Jose?
So that's a very good point. I don't like to say, what is the language feature? I like to say like pattern matching, because unless you use the functional programming language, you don't know what it is. So I started with with things like, what is the focus? And the focus is maintainability and scalability. And one of the things about maintainability in my experience with Elixir so far, and why I think it's a maintainable language, is all behind the idea of processes we were talking about. Right. So, for example, if you're thinking about maintaining application, there are 2 aspects of it. It's like it's running production, and part of maintaining it is to ensure it actually runs properly in production. So, if you never, I know you're already playing with Elixir, but if you never run with it, use it before, we have a tool called Observer that you can install on your node or connect to a node and run this tool, and it kind of shows the whole tree of our system. So Elixir applications, your Elixir software, your Elixir system is built into a bunch of tiny applications, and you can go one by one and introspect those processes, those lightweight threads of computation we were talking about earlier. So you have really a great amount of introspection of how your system works, and this matters a lot to ensure the software is running properly in production, which is one of the aspects. Just to give an idea of how this tool is useful is. So one of the things that we did with Phoenix and the whole channels idea and WebSockets idea is to make sure we got a very powerful machine for our rack space, and we're able to have 2 million connections on that same machine. So we had like 2 million clients connected to the same machine, connected to Phoenix channels, and we broadcast, for example, a Wikipedia article to those 2 million clients in like 2-3 seconds, right? And in order to make it go that fast, we had to improve it. So what we did is that we connected the clients, and then for example, at the first try, we're 300,000 clients where we reached our first bottleneck, or even 30,000. I don't remember exactly. But what we did is that we connected the Observer, and because it gives you this whole idea of the system, right? We could say, and because all the code run into processes, those lightweight threads of computation, when things started to go slow, we went to a pane and say, wait, which process is the one that is slow, the one that's doing a lot of work? Because that's the one that's going to be my bottleneck. And we say, that's the one that's being slow. Let's optimize it. And then we optimize, we move the bottleneck elsewhere. And we did this a couple times. And I think over the period of 2 days, we're able to go like to 2 million connections just by relying on this tool. And these we use as an optimization job, which is also part of maintainability, right? If things are slow, you need to go and try to understand your system and try to make it fast. So that's one aspect that we have to it. The other aspect that we have of maintainability is also related to code. So we were talking about this during the break. So for example, I think the whole idea regarding immutability helps a lot with that, and the whole idea in functional programming. So okay, let me just do a statement, and then we're going to explore a little bit
Do
further.
it.
I think a lot of the reason why Elixir software is more maintainable, it's because of ideas that we have that come from functional programming. And functional programming, if you ask someone like, "What is functional programming?" You're going to have to get a bunch of different answers. So one of the things that's usually associated with functional programming is the whole idea of immutability, and I'm going to expand this soon. But to me, the big thing about functional programming is that it pushes it tries to make the complex parts of your system explicit, and that's why it's so helpful. So, for example, mutation, right? Like changing things in place, it's a source of complexity because Rich Hickey, he has great talks on the topic, right? Because now you need to think of how that thing is changing over time, and if you remove the mutability aspect, right? If you make things immutable by default, you remove that whole time question of understanding your system, right? So mutability is source of complexity, so it needs to be more explicit. It cannot be the default. It cannot be something that you do automatically. And for example, another way this shows up in functional programming for using more strict languages like Haskell is the whole idea that any side effect that you have in your system, right? If your system is changing the word around you, like talking to the database or someone, in Haskell, you need to be explicit and use a monad. But here we don't have monads, right? But we go with this idea, if you want to do something that's changing the world around you, we want you to be explicit and put it somewhere more explicit in your code, and we want you to put it apart from the code that does not change the world around you. So what you have at the end of the day, you're like writing functions that receive data and transform this data instead of mutating it, which means like every time you call a function with the same input, you're going to get the same output. It's easier to understand what is happening with it. The state that it receives, it's always explicit. There is nothing happening behind the scenes. One example to try, like people listening, to try to visualize that. And for example, like when you're writing tasks for object-oriented languages, sometimes we always had to write that task where we had to set up a bunch of or mocks or relationships, or set up the state you need to get to before you can write the test, right? And that's because it has a bunch of states, a bunch of things related to it that it can mutate, that it depend on implicitly, right? It's like inside the object. But here we don't have that, right? Like you have functions and everything. There isn't an object state that is a consequence of calling something, right? Everything that you receive is explicit, and you need to return everything explicitly as well. And I think that makes wonder to make your software more maintainable, because now you can look at it and say, hey, I see what this is doing because I can look at a function and see everything it needs to work on. There are no inner state, right? There or a bunch of relationships that can change and affect the whole system. So those are some of the points for maintainability.
I'll just expand on that and maybe bring up a specific point when it comes to functional programming. One thing that you often find is you have this, like you said, you're just transforming data, right? So you pass the data to this function, then this function, then this function, and they all change it in some way, return a new thing that's a mutation of that previous form. And so you end up oftentimes or passing around the same, what I've called previously, just a bag of data, and doing things to it. And so my question is always like, well, why don't you just make that bag of data smarter, and then it's an object, and now it has its own internal things going on, and you get back to object-oriented programming. One thing that Elixir does, which I think is really cool, when it comes to like passing that same thing into as the first argument to all these different functions that are going to mutate it is you've introduced a way of just alleviating that little syntax pain, which is your pipeline operator, which is kind of like the pipe symbol and the greater than symbol. Can you explain us? I think that's one of the, if we talk about just language features, I think that's a big one. And maybe it's just syntax sugar, maybe not. But can you talk about the pipeline operator and what it does, and then why it seems to resonate so well with so many programmers?
Right. So the whole idea of the pipeline operator is actually to help you and to express like the whole, like I have the data and I want it to go through this step, this step, this step, like the pipe in your terminal. Right. And I added it, I think I added because I saw it in F# or ML or something like that. But who really took it like to the next level was Dave Thomas. So if you buy like Program Elixir book, the pipeline operator is right there in the cover, and he was the one who saw like, hey, this is the thing that's going to make Elixir click to a lot of people, right? And but yeah, the idea is very simple, and Elixir kind of said, okay, the subject is always going to be the first argument, which makes everything easier to pipe, and yeah, and that's it. And I agree with you that it kind of gives the idea, well, this is kind of object-oriented, right? Because I could think of, I had like this bag of data and then I could be calling functions on it, and the pipeline is going to resemble that. And that's why I think it resonates with a lot of people. But there is one very big important difference, which is if we made it objects, and the thing about object is that you are putting the data with the things that act on it together, right? You are
right.
Mixing
data
them
plus
together.
Code, right?
Yes, and one of the things that I end up realizing later is that it brings a bunch of awkwardness into our software, and then it kind of becomes a problem, and we end up trying to solve it, and ends up creating more problems in object-oriented languages. I hope that I do not sound like a snob saying those things.
I don't think so.
Yeah, it's
Truth
just
is truth.
yeah, it's just like things that I built with time, right? Like those perceptions. Because, for example, after you put those things together, right, you say, okay, now if I want to add something new that works on this data, I want to couple it together as well. So imagine that you have like your object that has a couple of methods that work on this data. We just couple them, and then you have an idea for a new method that you want to add to it. If you call it differently, as different from the other methods, if you cannot simply say object.foo, if you cannot say object my new method, it's awkward, right? So we want to put it in there with the rest of the things. And for example, Java does not allow you to do it. After you define, you cannot extend it. And then people are like, oh, now I need to subclass and so on. And Ruby is much more flexible on these matters, that we can extend things later, but it generates all kind of weird coupling now, right? Because I have now external code that may be monkey patching an existing class, and that adds issues. And that's all because we try to couple those two things in the first place, right? In Elixir, it doesn't, we don't, when you're using the pipeline, there isn't this awkwardness, because we are saying I have my data and I'm going to call the function bar from the module foo. And then if you want to add your own module with your own functions, you just call it next in the pipeline, right? I'm going to call my new function in this other module, right? And it's natural because that's how you're calling everything. And you can swap easily, change things, you can compose, you can replace the function calls, and you never feel that need to couple it together with the data, which to me, it's the big win, right? It also has the big win that, for example, if you have an object, you're saying object.foo, where is that foo defined? For example, in Ruby, where you can define things everywhere, it's really hard, right?
Right.
And you can even think it's defined somewhere, but some other file kind of replaced it by something else. But here you have modules, and after the module is compiled, it's done. It's a sealed deal, and I know it's in that place. And if I'm going to look it there, it's going to be there for sure. It's not going to move somewhere else under my feet. So I think those things they they matter a lot, and it's going to help us write more maintainable code.
Hmm. Let's talk about another aspect which you bring up around productivity, and you say it's because the tooling is good. And recently, we've had a lot of fans of Elm talking to us, especially after our show recently with Richard Feldman. One thing he said on that show, which was that the most exciting thing about Elm to him, which again, that's the best functional programming in their browser, is their pitch, is that the compiler itself is a huge benefit of using Elm. And I'm not sure if it was him or somebody else who said this idea of humane compilers, where they're like there to help you and to be useful, and not just like seg fault or just throw a syntax error, or not give you any information about what's going on, is huge for productivity. And that's something that Elixir seems to support. Um, as I said, I've been doing a little bit of Elixir, and I'll find that sometimes it tells me not just what went wrong, but like gives me a code snippet on like, if you would just replace your code with this code, everything would be all right. That seems like a pretty big feature. Was that a focus for the language early on? And can you talk about why that's such an important aspect of why Elixir is the way it is?
Yeah, that's a great question. So I always said, like, if you see a bad error message in Elixir, you should open up a bug report. Like, if you get an error and say like, I don't know how to fix this, I don't know what is the next step, I don't know what is wrong with my code. Open up a bug report, and you're going to try to make it better. Uh, and I don't think our compiler is as good as the Elm's compiler in terms of like telling you what to do next. Evan
Mm-hmm.
did really a great job with Elm, and having the static type system in that case helps a lot to provide the proper information. But it's something that we really try to do, right? Like, hey, I don't want to make you clueless, right? If something's wrong, I'm going to try to tell you as much as possible why that happened. And it was there since the beginning, because uh, what happened is that I want people to use Elixir, right? And if they're using Elixir, they need to learn a lot of things, right? They need to learn about pattern matching, as we're talking about, immutability. Now you no longer have objects, and things are immutable, so you need to think in terms of immutability. There is recursion. There are a lot of things that you need to learn, right? So those small things that can get in your way, the silly things, right? They're not the important ones. Like when I do a typo or when I do a small mistake, we need to get them out of our way. Or if they happen, I need to tell you, how to solve that problem and how to think in the proper way. So that's the reasoning for this, and it was kind of always there. It was something that we always wanted to, you know, let's make this learning process easy, so you can focus on the things that matter and not on those small details, on those hiccups that everyone have, right? When they are learning how to program on a new language. I remember,
Mm-hmm.
I don't remember who said this, but they said that their first Elixir code, they would just type whatever they think what it should be, and
Mm-hmm.
then the compiler would tell them, "Hey, that's not the proper thing," and they would fix it. And they got it working only with those steps, and he didn't have like to search on the internet, go on Stack Overflow, because the compiler, every time he did something that was not like the the thing that was supposed to be done, it was able to
Mm-hmm.
guide him towards the proper direction, which is really nice.
Yeah, absolutely. Getting stuck on those little things is always a burden, and it can really turn you off to a language when you just can't get it to work. So having it hold your hand as much as possible is huge. I think another aspect we talk about features. A huge feature in any language is the community, the ecosystem around it. We've been mentioning offhand Phoenix, which is the web framework. There's also Ecto, which is a database layer. And other projects that aren't Elixir proper, but they are things that you appear to be personally invested in with regards to time and effort, and decision making and stuff. When we had Chris McCord on back in episode 147, I asked him about you, and I was kind of wondering aloud. And I said, I wonder if the reason why you've been so highly involved, specifically in Phoenix at that time, is because you you see it as a chance to give Elixir a greater success. So if it has a killer web framework, Rails put Ruby on the map in America, at least, and made it something that was more mainstream. And so maybe if Elixir had a Rails-esque type of a project, or let's just say a really viable web framework that people could build web apps with, that would increase the chance of success of the language. I asked Chris if that's why you did it, and he said, well, I can't really answer that. I can't tell you why Jose does what he does, but you might ask him sometime. So I say all that to say this. Here we are. I can finally ask you. You've been highly invested in the web framework and in these web tools, and I just wonder the reasoning behind that, and if I was right on in the sense of, you see this as a path of giving Elixir its greatest chance for success.
Right. So I try to not vinculate whatever I'm doing with the chance of success, like directly. I obviously want it to succeed, right? But I try not to do things like directly because of that, right? So, for example, for the web in particular case, I said at the beginning, right, about platform attack, right, that we are a consultancy, and then we are working with projects, and most of our projects are web projects. So when I back in 2012, when I asked them to fund, the idea was that eventually we would have Elixir 1.0, and eventually we would have the good web tooling, so we can use it for ourselves. The company could use it and can start using Elixir in production and use with our clients, which is one of our goals. So that was pretty much the idea. So when I was working with Elixir, I had I don't want this to be a web-centric language, so I'm not putting things that make sense only for the web here. That's not what I want. But after we got Elixir 1 out of the way, I said, okay, I'm going to do the step 2, right? This is the second milestone, which is to focus on the web tooling. That's why I started to work more with Phoenix and work more with Ecto and so on. And other than that, for example, before Elixir 1.0 came out, I kind of built my own web framework that was not supposed to be used for anything, but just to give an idea how where the language was and what could I build with it and what could be improved. So that's something that happened. But I always try to keep this stuff apart. It was never the focus. So the main reason was really, if platform attack want to use this with clients, we need to have a very good web story. And that was actually the goal for last year. And I think we achieved it with a lot of success because Phoenix 1.0 came out, and it's not me, right? It's the nice thing about Phoenix is actually that I didn't have to solve that problem. Chris did most of the work. I'm just helping, and this is great. And then I think we were able to get really far with Phoenix 1.0, Ecto 1.0 came out. Now the community is starting to grow. We can see more and more companies using Phoenix. And I'm in the last steps. I'm working on Ecto 2 right now. That's going to improve based on some of the feedback. I'm also working with Chris and Bruce Tate on the Programming Phoenix book, which is also going to help with all of those things, right? But the main reason was exactly, it's just something that we'll need to use, and that's what I want to focus on. And yes, I kind of knew that if we have that, it's going to help with adoption, because when you have just the language, you don't have, let's say, a tool to use it with. This was actually very interesting because when Phoenix started to become more popular, it started to attract different, let's say, kind of developers they aimed on different things, because when you're learning only the language, you're focused, I want to learn the language and I want to master it. And when it comes to Phoenix, now we start to see more developers that are like, hey, I want to build something. And of course, learning the language is part of the process of build something, but it's not my goal on its own, right, per se, which is completely fine, but it's just interesting how the dynamics change. So yeah, so that's kind of the reasons. I think I maybe possibly answered your question.
No, you did. I find it somewhat interesting that you say you don't necessarily like to think about it in terms of what you do directly leading or increasing the chances of Elixir's success. I would expect it to be the exact opposite. Like you would you would want all your efforts to specifically try to advance the chance of Elixir's success. Maybe it's just not that deliberate. But that led me to this thought: is what does success look like? I'll tee this up. We need to take our final break, and this will give you a chance, Jose, to think about the answer. Is if Elixir is as successful as possible, like what does that even mean? What would a success story be 5 years down the road, 10 years down the road, that would make you sit back and say, yes, this was worth it. This was all that it could possibly have been. What would success look like? So we'll talk about that, and then we'll go back into more of the community stuff after that existential question right after this break.
We're excited to be working with BMC to spread the word about TrueSight Pulse, their SaaS-based monitoring service for cloud and server infrastructure that lets you monitor, visualize, and alert with 1-second resolution. I had a chance to talk to Mike Moran, the senior architect, about what real-time monitoring is. Take a listen.
Real time obviously means different things to different people. To us, real time is 1 second. So for us, we have 1 second metrics on everything that we collect. We'll pull all of that, push it to our servers, and you can see it roughly in about 4 to 8 seconds, depending on where that falls in the interval. So we'll pull 1 second data, and within 8 seconds, you can see it streaming live on your dashboard.
So during this conversation with Mike, I was trying to figure out what real-time monitoring means to them. And I was also trying to figure out who might use it and why they would care about 1 second resolution timing when it comes to monitoring their infrastructure. And this is how Mike broke it down for me.
I think at the beginning, you kind of looked at it and went, that's a very niche set of the market. But I think as things have changed, you can look at e-commerce companies, or you can look at anybody who's running an application. We now have stacks that are very nimble, and we end up with things like restarts that are quick, or our stats change very, very quickly now. So our spikes maybe aren't something that, it's not Black Friday and you end up with this gradual spike or this immediate spike that lasts for a long time. You now have a lot of things happening because you have so many interconnected systems and you have microservices and dependencies everywhere. Something happening in one obviously affects other things, but if it's something small or happens very quickly, you don't notice that.
And at this point with Mike, I was like, well, what's a better example? Give me a real world example that everyone knows about that can really explain how important it is to have 1 second near real-time monitoring on infrastructure level stuff that really matters, the heartbeat, so to speak, of an infrastructure. And this is what he had to say. It's pretty interesting.
If you're looking at your EKG and you're looking at your heartbeat, how many doctors would ever look at your heartbeat at a minute interval or a 15-second interval? You'd be crazy because you'd miss whatever was happening with your heart, and that's something that obviously you wouldn't want to screw with.
Wow, what a great real-world example of what that exactly means. I don't know about you, but I don't want to mess with my heart. My heart keeps me going. Your heart keeps you going. And if you value the heart of your business, the heart of your infrastructure, you're going to care about 1 second resolution timing. You're going to care about real-time monitoring. And BMC's TrueSight Pulse truly is something you should take a look at. Head to bmc.com/TrueSight Pulse, all one word, no hyphens, and tell them the Changelog sent you.
All right, Jose, before the break, we teed up a question for you. Kind of a big question. Look forward and think, what does success look like for Elixir? What could be beyond your wildest dreams a success story for Elixir if you're 5-10 years down the road?
Right. So before the break, you said that it was kind of surprising, that I didn't associate things like to increasing the Elixir adoption, right? Mm-hmm. And the reason for that is because it's to not generate any expectations, right? Because if I think something is the correct way to do it, and that doesn't lead to better adoption at the end of the day, I should not couple the two, right? In the sense that, what's going to validate if something is good or fair in the proper direction. Adoption is always great, but if the adoption falls because of something, it doesn't imply the cause, and I don't want to associate that in terms of the language building and the whole idea of just not having expectations. So your question basically of what I see as a success, I don't have really an answer because I try really, really hard to not build any expectation, right? To not try to think about it and just do what I think it's right and what I think makes sense, what's going to make easier to write maintainable and scalable software that we were talking about, and keep the developers productive, and so on.
Mhm.
So yeah, so I know that this question in particular, I'm not answering it, but it's kind of on purpose, because it's something that I try to stay really far from, and try not to get into. But there are
Yeah.
a couple of things that I kind of think like, oh, this would be nice, right? So,
Mhm.
I mean, in 5 years, what would really be nice if I am still working on Elixir, right? And there is a community, and we are continuing to grow. That's definitely something nice. I don't try to think of precise numbers or precise goals, but I obviously want that, right? And and as I said, I want to continue increase adoption. I thought I don't have it as an end goal per se. Also, I want to have a diverse community. So I don't want to be focused like only web, right? Because we have so much with the Erlang virtual machine and the ecosystem that's already there for building concurrent distributed systems. And so I really want to build more and more around that and go beyond web, right? So if you're doing things that are more low level or building distributed systems, I want to see more of that happening. And I've already seen there are like good talks happening at the Elixir conferences about going more toward the distributed system approach and not necessarily web, which is really interesting. We can learn a bunch of stuff. One of the things that we mentioned about Phoenix, so in Phoenix 1.2, we are going to have a presence system that allows you to say, hey, someone came up online. And the work being done, it's really nice because it's going to be completely distributed. So we don't need a database to persist your presences. If you have like 3 nodes and you put a new node up, the nodes are going to talk with each other, and it's going to synchronize the data. So we have the whole distributed system working, and we have the whole presence system working. If the nodes come down, everyone that's connected to that node is going to come down. That information is going to go across to the other nodes as well and update the presence status, which is very interesting ways of doing stuff. And Chris and Alexander that are working on that, they are using, like a bunch of research papers that are from this decade, which are interesting things happening. And I hope it's going to bring more distributed focus folks to the language, right? And help build more on that area. And that's kind of my vision. That would be really nice. I know also there are a lot of folks working on embedded Elixir, and starting to hear more and more. There is a fantastic project called the Nerves Project that's trying to make it really easy to build embedded software and deploy to your hardware or whatever you have. And I think that's something nice, right? To go and have a diverse community where I can learn more about embedded, I can learn more about distributed systems. One of the things I want to explore for future Elixir versions is something more related to streaming data, right? So if you have data coming in and you need to process it in different ways and send it out somewhere, we want to make that as efficient as possible, which I hope is going to bring more data-oriented folks, right? And so on. So that's kind of like my view. It would be really nice to have really a diverse ecosystem and have like all these different kinds of things happening in the community.
Very good. You mentioned the presence feature, which sounds totally awesome. I know something similar specifically to Phoenix is coming down the pipelines with regards to presence. And we have a bunch of Phoenix and Ecto related questions for you, Jose. And as we talked about in the break, we're running short on time here. So we're definitely going to get you back. So listeners, stay tuned for a upcoming show with Jose, and perhaps we can get Chris on as well to talk specifically about, web stuff with regard to Elixir, because I'm all for diversity in that community, and that's an awesome goal for you and one that I hope you achieve. That being said, the web stuff is very exciting to many of us for sure. But now let's just close with talking about getting started. If you have people out there, they're probably excited about Elixir. Maybe they've dipped their toe in the water, but they got a false start. Specifically, we had some members in our Slack room talking about getting started from the perspective of somebody who hasn't done functional and is really an object-oriented programmer historically. And they're wondering what your specific advice is coming from that angle, getting started with Elixir and Phoenix and the whole ecosystem. What are some ways beyond like go Google, for things like what are some really solid ways that people can dip their toe in the language?
One option is to go to the website. We have a really, really good getting started guide, and I'm saying that because a lot of people they tell me that like I read the getting started guide. It was fantastic. It went for through the most important things I need to know and to get started. So that is a getting started point, and we have already a bunch of resources available. So there is the Programming Elixir book we talked about from pragmatic programmers, which is going to go you through the language and cover a bit of the aspects of building systems. But we also have, let's say, more advanced between quotes books like Elixir and OTP in Action or Elixir in Action from Manning, which is an excellent book that's more focused towards the aspect of building systems, and it's trying to put you more into the mindset of building systems in Elixir. So those are very good starting points. And the question about object-oriented, um, I would say I wouldn't worry because I like the majority, for sure, the majority of the Elixir ecosystem came exactly from that background, right? So, you're going, if you're stumbling, you're going to find resources or you're going to talk to developers. So we have a Slack room if that's more of a thing. I am particularly on IRC. We have an Elixir Link channel. So if you're having troubles not understanding some particular mindset, you can you can go for the resources set above, but you can also hop in one of those channels and ask questions like, hey, I'm having trouble to let go from some of those particular things, or I'm having trouble to express this particular thing that was easy to express in object-oriented language. So what is the correct way to do this here? And we are going to have discussions around it, and hopefully you'll be able to get started and have fun.
So we obviously have some closing questions to this deep dive. I got to say, I'm really excited that we've had you on the show. I'm more than thrilled to see your path from beginning programmer to where you're at now with Elixir and this community, this budding website and embedded side, and so many opportunities for you. And I'm glad to see that you're authoring a book and going to be at Strange Loop in 2016 to give that talk on the Erlang VM. And one thing our guests love to talk about when they come on the show is kind of not just where they came from, but who out there may have influenced them along the way. So this is a chance for you to kind of mention somebody that's been a hero to you. So who's a programming hero to you, and why?
Sorry, I'll have to. There was a misunderstanding because I won't be on Strange Loop 2016.
Oh,
no, so that's the talk I gave in 2012. It was when I was telling about the background. Maybe I didn't express myself properly at the time.
Well, we got some issues then, because I found a page on Strangeloop 2016 Elixir Modern Programming for Erlang VM. Was that in 2012 then?
That was 2012.
Okay, that's my bad then. So I saw it on the site and I didn't find it anywhere on their YouTube. I'm like, okay, he hasn't given this talk yet then. So I thought I heard you say it was in the past, but I wasn't sure. We'll leave that in. We won't edit that out. We'll let that blip be there. And we'll obviously let Jose be the correction there for it. But nonetheless, besides that, who's your programming hero?
So that's a hard question, but I will go with Guys too, because he did a lot of work on a bunch of different languages, right? From everything you can think of, from like Scheme to Java, and taking part of in things related to JavaScript, Common Lisp, C, and so on. So he has been a great influence on the many of languages, right? That the industry uses as a whole, and he has great talks. I like to say like my favorite talks of all time is a talk from Guys too on building a language. And usually when I'm talking about Elixir, I have a quote from that talk that a language needs to be a pattern for building more languages, which is the reason why I always wanted Elixir to be extensible, right? Because our field today is so so wide that the language needs to be extensible. You need to be able to get it and take it to the domain you are working on. So yeah, I would definitely go with guys too.
Guys still. All right. And aside from your hero, what is on your open source radar? Obviously, you're writing this language Elixir and you're doing so much more around it. But what else out there is on your radar? What's out there in the open source world that's got you excited that if you had a free weekend that maybe wasn't Elixir focused, or maybe it is, might paint back into the future you sort of described a bit ago? What's on your open source radar?
So there are two things to that. So one is the Nerds project I talked about. It's part of the Elixir Link community, but they are doing a great job with the everything embedded, and it's something that I'm saying, oh, I need to play with it more and maybe help in any way I can if I can help. So that's definitely something that is in the radar. But regarding the whole, like future of Elixir, I said like streaming data. So I have been following what is happening, with Apache Storm and Apache Spark. It's things that I am like following on the side, reading about it. There's also the Microsoft Things project. It's really interesting. I've read the papers, but I haven't played with it yet. Something that I plan to do.
What was the Microsoft thing?
Microsoft Orleans about virtual actors. So they use that, for example, when deploying Hello. So the whole idea is that, so today in Elixir, you're kind of like, if you're starting a process to execute a computation, you need to tell exactly, I want to start this process on this particular node, right? So you always need to give that information. And the idea behind Microsoft Orleans, they call it virtual actors. So a good thing there would be like virtual Elixir process. So for example, if you have a Halo game, you would have, if you just joined in and you want to play on multiplayer, for example, you would send a request to their cluster, and the cluster would start like a process for you, like similar to the Elixir process, but anywhere in the cluster. You don't say, I want this thing here, I want this thing there. They take care of that for you, right? Which means that if you are not worried about location, for example, if you're having high loads, what you can do is that you can plug more machines, and because you don't really care where that particular process is, you can move it around, right? So you can say, okay, I'm going to move this from this machine because this machine is having a spike right now and cannot handle the load. So it has a bunch of interesting ideas in there regarding virtual actors and process placement in a cluster, which would be nice to explore.
Very cool. Well, like I said, it's been a blast having you on the show. I know we've kind of teed up a tease of a potential, I guess, take two on this to get you back on, and also Chris to talk deeper about the website of Elixir. So if you're listening to this, stay tuned to that. We also have a bunch of great shows in the schedule coming up. Free Code Camp with Quincy Larson, TiddlyWiki with Jeremy Rustin, and a big one for us we're excited about, the future of WordPress and Calypso with Matt Mullowig. So those are some upcoming shows for us. But Jose, before we close out the show, anything else you want to mention about Elixir, about anything we've talked about today before we close out the show?
I just want to thank you for having me. It was really fun. And if you heard the podcast, go give Elixir a try. We talked about it, and try to join the community. There are a bunch of ways, but if meetups or getting, like with other developers more of a thing, you start to subscribe to the Elixir Radar. Do that because we have a meetup section that is telling all the meetups that are happening with Elixir around the world, and then you can find something close to you that you can go. But there's also a bunch of conferences coming up. We're going to have Elixir Days in Florida. We are going to have Elixir Conference in Europe, here in Berlin, around May. And the Elixir Days in Florida is March, if I'm not wrong. And we also have Elixir Conference in the United States about August, September in Florida as well. So, wow. Come and be part of the community.
Yeah, a lot of stuff coming up for you then. Yeah, that sounds really good. So we'll make sure we link to a lot of things here. Definitely the newsletter you mentioned, back to the intro to the site, a lot of links in our show notes. So this is episode 194. So if you're listening to this, go to changelog.com/194. Or if you're using a podcast app, check your show notes. There's all the links in there. Don't wreck. Don't pull over and try and write it down. We'll just use the show notes for that. But Jose, it was awesome to have you on the show today. I want to give a special thanks to you for taking the time to be in the nighttime, because we're in different time zones, so you had to really work hard to work the scheduling out with us. We appreciate that. And to those listening, thank you so much for listening. And to the sponsors, TopTile, Linode, Rollbar, and also TrueSight Pulse, thank you for supporting the show. But fellas, that's it for this show, so let's say goodbye.
Goodbye. Thanks, Jose.
Bye. Thank you.